In this video, I'm going to show you how you could build a data-driven web application in Python for web scraping S&P 500 stock prices. And without further ado, we're starting right now. Okay, so the first thing that you want to do is fire up your terminal. So today I'm going to use a Microsoft Windows, and then I'm going to, as always, activate my Conda environment. And the files are on the desktop. And so I'm going to provide you the links to the files described in this tutorial. So you want to check out the video description. SP500. Okay, so you're going to see that the only file that we're going to use is the sp500-app.py. So let's have a look at that. And before doing that, let's also open up the web app. Streamlit run sp500 app.py. Alright, so here we are. Okay, and so you're going to see that in the web app, we're going to have a sidebar on the left. And here we're going to have two input features. The first one will allow us to select the sectors, and the second one will allow us to select the number of companies. And the data for the names of the company in the S&P 500 was taken from Wikipedia. And so I'm going to show you where we got that. The links is right here. Okay, so the table that we're going to web scrape is this table here. So we're going to see that it has the symbol for the company, the name of the company, and other information like the sector and the sub-industry sector, the headquarter location, and also the founding date of the company. And notice that there will be two tables, and the second table will be here. But for the purpose of this tutorial, we're going to use only this table here. So before we take a dive into the web application, let's have a look at how did I created the essential functions for making this web app. So let me first go to Google Colab. So let me expand this a bit. Okay, so here is the details of how we're going to make the web application. So firstly, we're going to create a function, a custom function that will allow us to web scrape the data from Wikipedia. So here we're defining a function called load data, and then the first thing is we're going to put in the URL of the S&P 500, which is essentially right here. And then we know that we're going to take this table. So the prerequisite of web scraping using Panda's read HTML function is that the data must be in a table. So if data is in a paragraph like this, it wouldn't work. So you would need something like Beautiful Soup and Selenium in order to do that. And because the data is organized in a very simple table manner here, we're going to just specify that we want the first table. So we're going to specify this to be 0, okay, and then the data will go into the df, which we will return here. And upon running this cell, let's do it. And so you're going to see that the web script data is provided in the df variable here, and it looks very nice. Let's take a look at the sectors here in the fourth column, sector. So we're going to select the sector column from the df data frame, and then we're going to take out the unique count. How many unique sectors are there? And so we're going to see that there are a total of 11 sectors comprising of industrials, healthcare, information technology, communication services, consumer discretionary, utilities, financials, materials, real estate, consumer staples, energy. Okay, and then so let's say that we're going to aggregate the data by grouping them according to the specific sector name, which is comprised of 11 different sectors. And then we're going to show only the first company for each of the sector of the 11 sector. So we're going to see that for each of the 11 sector in the first index column here, we're going to see the first example of the company name. So this represents the first company for each of the 11 sectors. Now let's do a descriptive statistics of this sector variable. So we're going to see that there are a total of 26 company in the communication services, 60 company in the consumer discretionary, 32 company in consumer staples. Let's take a look at only the healthcare. So let's take a look at only the healthcare sector. So we're going to use the get group function. And then here, we're going to see 63 companies. So all of the companies here are belonging to the healthcare sector. Okay, so this first part are data derived directly from the Wikipedia website. And now let's do a second part where we take the names of the S&P 500 and then we're going to retrieve the stock price data from the yfinance library in Python. So the first thing is to install the yfinance library. Okay, and so now we have installed it, and now we're going to import it as yf. Okay, and so here, these are the list of the company symbols from the df data frame that we have got above, where we web scraped from Wikipedia. So here, all of the company names are here. And now we're going to retrieve the stock data. So using the example code from this URL directly from the yfinance PyPy project webpage, there is a function to download the stock price data. And here we're going to use the period of YTD, which is the year to date. So this will be from the beginning of the year right until right now, which is October 6, 2020. And then the ticker will be all of the data in the S&P 500. So there's going to be more than 500 companies here. And then the data will be grouped by the ticker, which is the symbol of the company. And then everything else, we're just going to leave it as default. All right, so let's run it. So this should take a moment because it's going to download all of the stock price data from the yfinance, and it will be placed into the data frame. And note that the interval is 1 day, which is also the default. And you could feel free to change the interval to like 1 minute, 2 minutes, but then this will generate a lot of data. Or you can make it in monthly intervals as well, or even weekly intervals. All right, and so it apparently is finished. Let's have a look further. So it's saying that 2 companies could not fetch the data from BF and BRK. And 505 have been completed out of the 507. Okay, and so this is the stock price data, and you can see that the price information are grouped according to the ticker symbol here. And then you could easily retrieve specific companies by specifying it in the bracket. Okay? And then you get the data that you need. 192 rows because it is starting since January until right now, which is October, 192 days. Okay, and so what we're going to do here is we're going to move the date to be one of the column. As you can see that now the date is part of the column here, and we want to make use of the closing price. So our new data frame will contain 2 columns, the date and also the closing price. So you could feel free to play around with the price data if you want to use the open or the high or the low price. But for this tutorial, we're only going to stick to the closing price. Alright, and now we're going to do the fun part. We're going to make a plot of it. And so this is the plot of the closing price. And in the x-axis is the date, and the closing price will be in the y-axis. So you're going to see that the price is dipped around April, and then it kind of went up. And if you compare from beginning of the year until right now, the price is about $18 higher. Okay. So let's do the same thing, but then we're going to make a custom function. And the reason for making a custom function is that it's going to make our life and the reason for making this custom function is that it's going to make our life much easier because we're only going to specify the name of the symbol as the input argument, like right here. And then it's going to make the plot for you, like here. That we don't have to copy the entire code here and modify it to suit the name of the ticker symbol. So we're going to make a general helper function. Let's do it here. So the custom function that we're making is called the price plot. And then we're going to use price plot, and then the input argument will be the ticker symbol. We could change the company if you like. All right. And then you're going to see that the price is updated now. And then the beautiful part about this is that we can even run it as a for loop. So the price plot will be inside the for loop, and then we're going to iterate through all of the company names, but then here we're going to select only the first 10 companies. Okay, I have to run. Oh, okay. We updated the name here. DF. Okay, we're using the same name. Then we have to take the name here. We have to rerun the load data function. Okay, and now it will be reassigned to the DF because previously we have overwritten the DF variable name and it is lacking the symbol column right here. Right here, we have overwritten the same name, so I think we should call this something else. Let's call it DF2. And then this will have to be DF2. Right? Let's do it again. This is DF2. And then... okay, it works again. It should work now because we have already run the symbol here. DF symbol. Alright, it's working. And we want the first 10 companies. Alright, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, there we have it. And so the proof of concept is now working, and we have tried the proof of concept directly on the Google Colab. So the great part of making this proof of concept on the Google Colab is that we could be quite flexible in working on different computers using the same Google Colab. And once we're finished with that, then we could start the production phase where we will deploy it to the web application in Streamlit. And so now we're ready to deploy it onto Streamlit, and let's do that. And there you go. We have already deployed it to Streamlit a couple of minutes ago. All right, and so let's take a look at this web application. So in the user input here, we're going to have the name of the sectors where we could essentially select the sector here. And then we're also are able to select the number of companies that we want to show in the show plot area. So if we have 2 companies, then the show plot area will also have 2 plots. up to a maximum of 5, and the maximum of 5 could be changed to another value that you would like. Okay, and so I'm using 5 just an arbitrary number, and here we have 5 plots. And the great thing about this is that you could also modify this web application so that it will be tailored to your own country's stock price. So let me know in the comments how you're making use of this or how you are modifying this web application. And if you would like to share your creation, let me know and I could share it on one of the tutorial videos where I could show how to recreate the web application that you have made. And so drop me an email, and the email will be provided in the description of the video. Okay, and so let's take a line-by-line look at the explanation of the code. So here, the first 7 lines will be importing the necessary libraries. So first one is the Streamlit, the second one is Pandas, and we're going to use Streamlit because this web application is built on top of the Streamlit library. And we're going to use the Pandas because of the data frame by which we are showing the data. And then the base 64 will allow us to encode the data so that we are able to provide it as a CSV file. And here we're going to use matplotlib for making the plots. And apparently we didn't use Seaborn. And so let me delete that, and also from here. All right. And we also have yfinance. We're going to add it here. All right, and so that left us with a total of 6 library. And then the next one is NumPy and yfinance. Let's see, did we use NumPy? No, we did not use NumPy. Sorry. Because I was using a previous web application as the template for this one. So even less, now we're having only a total of 5 libraries. So yfinance, the 5th one, is going to allow us to retrieve the stock price for the S&P 500. And so you're going to see here that we are making use of only 5 Python libraries. All right, and so the st.title will be the function that we're going to use to make the title of the web application here. S&P 500 app, shown as a bold text here. And then we're going to make use of the markdown function in order to display the details of the web application, and also the libraries that we're using in Python, and also the data source, which is taken from Wikipedia. And then we have the st.sidebar.header. It means that we're going to create a header called user input features, and then we're going to put it inside the sidebar to the left here. On line number 19, we're going to say that we want to catch the data if it has already been run for the first time, so that the second time or subsequent time, it wouldn't need to re-download the data again and again. And so it only needs to do that only once for the first time. So lines number 20 to 24 is a custom function that we have taken directly from the Google Colab, where we have experimented with the creation of this web scraper of the S&P 500 data. And so we just paste it right here. And then we're going to assign the web scrape data into the df data frame. And then we're going to group by the sector name, which is right here. We're going to group by the, it's not showing here. Okay, right here. We're going to group by the sector names on line number 27. And then lines number 30 and 31, we're going to display the sector name as an option where you could select. You want to select only particular one. Here we are only selecting communication services. And so we're going to see that there are 26 companies here. Or we could also add one by one, the companies that we like. I mean the sectors of the company that we like. All right, and then line number 34 is only going to filter out from the entire data frame the sectors that you have selected in the user input feature panel here. So it's going to use the isIn function in order to see which are coming from the selected sectors right here. 3 selected sector, which is right here. Selected sector coming from the sidebar and multi-select function. Multi-select means here we have multi-selection. And now the data will be in the df selected sector, and then we're going to write it out here in the st.data frame, and the input argument is df selected sector, which is coming from here, and it's filtering all data belonging to the 3 selected sectors here, or it could be 4 right here. Okay. And in lines number 37, it's going to write out the dimension right here. Number of rows and number of columns. And the st.header will be the function to display the header here. Alright, and lines number 42 until 46, it's going to be the custom function to allow us to decode, encode the data, and make the CSV file of this data available for download right here. And then you get access to the CSV data. All right. And then the second part is the finance data that I have shown you just a moment ago on the Google Colab. And so here we're going to make use of the custom function that we have already done just a moment ago. And then for this example, we're just going to limit it to about 10 companies. Otherwise, it might have taken longer to create the web application. Okay, and so let's have a look further. And then the custom function to make the plot was also taken from the Google Colab. And so lines number 52 until 61 will download the data of the stock price directly from yfinance. Lines number 63 until 73 is the custom function to create the plot that we're going to see here in the show plot. Okay, and line number 75, it is the slider for you to select the number of companies. So if you want to make it into 10, then you could do so as well. Modify that to be 10, and then the number here will then be 10, and now you could have 10 plots. Okay, you could have 10 plots now. And make sure to play around with this number as well. Make sure that this number is greater than this number. Okay, because it will be the total number of stock price data that you're going to have. Let me change it back to 5. And let's say that you don't want to hide the plots here. You just want to show it. You could hide that function, the if. Let's see. It's indented. Okay, let's see again. Alright, and now you have the plots immediately. If this is 10, then you're going to get the 10 plots right here. Okay. Okay, and so if you're finding value in this video, please give it a thumbs up, subscribe if you haven't yet done so, hit on the notification bell in order to be notified of the next video. And as always, the best way to learn data science is to do data science. And please enjoy the journey. Thank you for watching. Please like, subscribe, and share, and I'll see you in the next one. But in the meantime, please check out these videos.